Welcome back everyone. In this video I just want to cover off on some of the issues that I found during the valve testing in the last two videos. So let's take a look at it. Well, the first valve we had troubles with in the first video was the 6M5 power pentode, which is used as the audio output stage. I did a quick search on the web and there wasn't a direct replacement that I had data on, and the closest I could come up with was the 6BQ5. So I've got both data sheets up here at the moment, and they are quite similar when you look at the specifications. However, there is a noticeable difference in that the screen grid on the 6M5 is bored out to pin 1 on the base, and on the 6BQ5 the screen grid is bored out to pin 9. So to actually do a replacement with that particular valve, you'd need to do a wiring change. All the other wiring on the base is the same, so no issues there. The other thing that I noticed I see, which I alluded to in the previous video, is internal connection. And they're a little bit different between these valves, and that's what those lockout switches are for, to basically isolate the internal connections that will actually indicate as shorts. 6BQ5 is 1, 6 and 8, which 1 internal connection, 6 internal connection and 8 internal connection, whereas on the 6M5 we've got 6, 8 and 9 showing us internal connections. Because 6 and 8 is common, it wouldn't have shown up an internal because all of them would have been isolated by those two switches. If you scroll down through the actual specifications for the actual device, maximum ratings, if we take a look at plate dissipation on the 6M5, we're at 9 watts and 12 watts on the 6BQ5. So the 6BQ5 is a slightly more powerful valve, I suppose. Looking down into the typical operation, in the case of this particular device, we're using it as a Class A amplifier rather than a push-pull where you'd use two valves. So looking at these figures here, say we look at the 250 volt plate voltage example, the plate current 36 milliamps and 36 milliamps here as well. So relatively similar. Load resistance 7,000 ohms. Now watts similar as well, 4.3, 4.8. So quite similar devices. So on that basis, I'm fairly comfortable in saying that the test result, which was sort of, I think it popped up into the average zone and then sort of sunk back into the good zone, I'm relatively happy to say that that valve is certainly not good and a little bit average. I've actually been able to find some 6M5s that are available on eBay as new old stock. So I've ordered some and I'm waiting for them to come in. So I think that valve there will be a replacement. The next valve that we had a problem with was the 6V4, where it was showing some shorts on pin 6 and pin 8. So I've brought the data sheet up for that particular valve. Let's just expand it a little bit further. And you'll note on the base that it indicates here 2, 6, 8 and 9 internally connected. So a little bit unsure as to why it didn't show up as short on 2 and 9 as well. However, potentially there's some little differences between different manufacturers or something like that. However, we can pretty much ignore those short indications because they're just on those internal connections and aren't part of the active valve itself. Okay, so the next valve we had an issue with was the 6BD7. Now, the first thing we found was it was indicating a short on 7 and 9. So just looking at this data sheet here, pin 7 shows up as a internal shield and 9 shows up as an internal connection. And I would suggest that they're both connected together. And again, the manual here doesn't specify that as needing lockouts. So I've penciled that in to the valve data, and I'd suggest that both those short indications are really no issue whatsoever. The other thing that was showing up on here is we had, this is a 3-element valve in that it's a double diode and triode, and one of them is used in the Philips receiver to drive the push-pull output stage, and the other one is used as a audio amp stage, and one of the diodes is used as the detector, and from memory I think the other one may drive the AGC. However, what we were seeing in both instances, the diode element on pin 8, diode number 2, was showing poor in both tests, and the other two elements, the diode number 1 and the triode, were showing okay. I think this may well be a further error in the book regarding the 6BD7. The tester is basically testing the cathode emission, and as it's a single cathode for all 3 elements, really the test should show up fairly similar, you would expect. The fact that both valves indicate pretty much exactly the same is odd for a start. You wouldn't really expect that, especially in one case where the diode elements aren't used at all. However, the other thing that I do note, the load setting is the same for one of the diodes and the triode and different for the other diode. I think this is potentially a misprint, and the 2 diodes should be the same and the triode should be different. If we do scroll down through the information, what we find here is basically both diode sections are treated much the same, hence why I think there's an error in the documentation. So I'm not prepared to write either of these valves off. I think they're probably both okay, and there's an issue with the documentation here. I guess time will tell on this front, but at this point I'm prepared to call them okay, and I've updated this manual. The 6BH5 also gave some grief. It could not be found in the test data. So I've done a comparison with the 6BY7, and although a different pin out, the operating characteristics seem to be quite similar. So the values here are not dissimilar, at least. So I've gone ahead and basically created some test data for this particular valve, taking into account pins 7, 8 and 9 being needed for the lockout, and using the same load and selector setting for the test. So we'll run this valve through the tester and see what sort of results we get on that basis. So the next issue was the 6AN7. It doesn't exist in the valve test data. So this one's created a little bit of a problem because I've had a look around for another triode hexode frequency converter, and there just isn't that many around. So I started looking a little bit further afield and have found the 6AJ8, which is actually a triode heptode converter. And looking at it, it seems like a reasonable comparison at least. There are differences between the two valves, but what I was looking for was being able to generate some test settings, and it would appear to be okay. The main things I was worried about was the settings for the load and selector when doing the test, because I wanted to be representative of the 6A and 7. So there's a totally different pinout, of course, but looking at the operating characteristics of the two valves, if we take a look at the triode as a oscillator, which is how it will be working in both cases, we're seeing similar plate currents and quite similar parameters all round. And if we have a look at the hexode section as a frequency converter, again we're seeing similar sorts of values. Not exactly the same, obviously, but I think similar enough that we can use it as a comparison, if nothing else. So basically what I've worked out are the settings that will need to be in the valve tester, taking into account the different pinouts, and I'll actually give that valve a test in the tester using that and see what results we get.